Hello everyone. Today I want to talk about introduction to calculus, namely basics of integration. So what is integration? Let me show you from very simple examples to more difficult over time. So integration is an operation on functions. You can see an example of a function here, f of x equals 2x. This is a stable function, constant, doesn't change. The result of integration depends on the type. So we have indefinite integrals and definite integrals. You can see an example of indefinite integrals here on the top right corner, and below you can see definite integrals. So indefinite integrals transform a function into another function. So you had function 2x and now you have function x squared. Definite integrals give the area under the curve of the function. So see, we have a definite integral, and the solution is this blue area in the shape of a triangle, because we have a kind of a range here from 0 to 3, right? So beginning is 3, later it ends on point at x equals 0. And if you calculate this, you will have 9, so it will be like, for example, 9 square centimeters. It would be the area of a triangle. If you calculate it with the formula of a triangle, you will obtain the same result. So we almost all freshmen students of the first year of various scientific, computer science and other majors learn calculus, not only math majors. So the question is, why learn it? It helps. I think that after studying calculus, I noticed that it helps to consolidate algebra knowledge, because a lot of algebra is needed for this calculus. It relies mostly on formulas rather than complex reasoning. And once you master the formulas, you can solve problems effectively. So it seems very difficult at first glance, but it may not be extremely difficult if you memorize all the formulas in comparison to some other more abstract problems. How to read this? We can see a symbol of integral. This is integral. This is like a extended letter S. So we often see this dx. It means that dx tells us that we are integrating with respect to x. It shows which variable is changing. So x is changing, not the number. So just like you have 2x dx, you see x is changing, becomes x squared, and 2 is not the one which is changing. Okay, what is we need to start with? We need to know examples of basic. We need to know basic formulas. In order to solve integrals, we need to know the formulas. So I have some examples here. First formula is integral of a constant. It tells us n dx equals nx plus c. So n can be any number. This is a symbol of a number, constant. So for example, 4x dx equals 4x plus c. So 4 integral of a constant give constant plus x, constant times x. Another example, but it's already using a power rule. This is very common. You can see power rule here. So if you have a x in this place, you need to apply this power rule. So you increase the exponent by 1 and divide it by the number, the same number as you have in the exponent. You may have a coefficient before, so you can write this coefficient before for clarity. And what is important, this power rule doesn't apply for x equals minus 1. So if x equals negative 1, we will use different rule, which I will show you later. This is example of applying this power rule. Sometimes when there is coefficient, like here 2x7, we can factor out the constant. This coefficient, factor out it before the symbol of integration, integral symbol, but you may as well do it faster way like this. Both are correct. We should also know what is differentiation, and that integration and differentiation are reverse operation. So the result of differentiation is finding derivative of the function. So for example, yeah, you have we notice we use this symbol to indicate derivative d over dx. So we had a function, you see there was a function 3x squared dx equals x to the power of 3. And you can see that this is a reverse operation because using this formula nx n minus 1 in the exponent, you will notice that calculating derivative from this integral will lead to exactly the same value which you had. So derivative of x to the power of 3 is 3x squared. And we should also note that constant c disappears when taking the derivative. Derivative operates only on x. So please take a look. We have x to the power of 4 plus 7. It will be 4x to the power of 3. We will ignore this 7. We don't need to include this in the calculation. So let's solve some integrals. For these integrals, you see we're gonna use power rule. So let's apply power rule. So we can split it into several integrals. So it's gonna be like x. Yeah, let's type equals x to the power of 3 plus 1 divided by 3 plus 1 plus 6x to the power of 3 over 3 minus 8x squared divided by 2 plus 2x. So what you can observe here that we will simplify this and over there, so it will be 2 here and here will be 4. So it's gonna be 4x to the power of 4 over 4 plus 2x to the power of 3 minus 4x squared plus 2x plus c. Here we need to always write this constant at the end. This x to the power of 4 by 4, you can also write it as 1/4 x to the power of 4. That would be also correct. It's possible. Okay, so we solved the one. This is the answer. Let's solve another one. I think that this case is more challenging, but it's very useful in learning because it will tell us how to operate on fractions. Okay, so we can write it that this, okay, number 2, this one we close it. Number 2 equals integral of 5 dx, integral of constant, plus integral of 7x to the power of negative 1/4. So what does it equal? Of course, okay, this is also dx, so it equals 5x, because integral of constant is 5x, plus, you can write a simple 7 before, and you will write x 1 plus negative 1/4, because we apply powerful, so we need to increase the exponent by 1, and we need to add 1 plus this fraction over negative 1/4 plus 1. So negative 1/4 plus 1 is equal to 3 quarters, so it will be 5x plus 7 to the power of 7 times x to the power of 3/4 over 3/4. Then it's gonna be 28 over 3 x to the power of 3/4. Why? Because this is 7x, right? You can write it like 7x divided by 3/4. So you know that dividing fraction is multiplying by the reciprocal, so it's gonna be like 7 times 4/3, right? That's why it's 28/3. Okay, that's the answer. Let's go to the next one. There is something we should know is converting roots to exponents, and there is also exception rule that if we have 1 over x or x to the power of -1, we don't apply power rule, but it will equal to natural logarithm and absolute value of x plus c. So how to apply this rule? Generally in calculus, when you solve integrals, you should convert roots. When you see a root, you should write it in an exponent form. So how to write it in an exponent form? Okay, so you will see that 3 will go, yeah, you replace the place. You replace the place, so you can write it like that. It's gonna be not square root, but you need to write it in a form of exponent. So it's x to the power of 1/3. Yeah, x to the power of 1/3. That is how we write it. Why? Because by default is x to the power of 1, and here is 3. So from this formula you take b first as a counter, and a, what was 3, goes like a denominator of the exponent. Therefore is x to the power of 1/3. And how to calculate? Again, you need to apply power rule for this. So power rule for that will be x to the power of 1 plus 1/3 over 1 plus 1/3. So it's 4/3. So it's gonna be x to the power of 4/3 divided by 4/3. And again, you see you can apply this method of dividing fraction become multiplying by reciprocal, so it will equal to 3/4 x to the power of 4/3. And that's the answer. Another one, maybe you can solve it by yourself. I'll just show you how we can convert it to this root to exponent. So it's gonna be not a root, but it's gonna be x to the power of 4/3. Right, 4 goes as counter, cube root goes as denominator here, and then you will calculate integral from this. Use the same rule. Okay, here we have something interesting. From this example, we're gonna apply the rule which we see here, and also we will use this knowledge about dividing exponents with the same base. So you can write it as this: x squared plus x to the 7th. It can be split into two fractions. So x to the power of 2 divided by x to the power of 3 plus x to the 7th and with the same denominator. So it will equal x2 minus 3. So the first one will be x to the power of minus 1, x to the power of negative 1, plus x to the power of 4, to the power of 4, divided by, not here will be divided by, there will be no division. Here will be no division because we already removed the denominator. So what we're gonna do here, it will be 1 over x, because we know from this formula that 1 over x equals x to the negative 1 plus x to the 4th. Okay, so 1 over x is gonna be ln x plus 1/5 x to the power of 5. Because for this we can apply power rule, but for the first one we cannot apply power rule, because according to, this is the exception, that 1 over x, it gives a natural logarithm absolute value of x, right? And this is the solution, natural logarithm x plus 1/5 x to the power of 5. And please mind you that this is not only about 1 over x, but any number, any natural number here over, and sorry, any number over x will lead to the natural logarithm in solution. So we can see it in this case. Let's solve this. Let's solve this one now, and you will see this is an example that we can simplify it, right? That's 6x over 2x squared. So what you can do, you can simplify this, so you get 3x over x squared. Then you will simplify 1x, so you have 3 over x. It will equals to 3 ln x plus c. So if you have 1 over x or x to the negative 1, you will receive this solution. And also if you have any number over x, like here, you will also have this solution. You will have to write 3 before the natural logarithm. These are important information. Finally, it's just I want to tell you, this is just the beginning. As you can see, there are so many other formulas, and these formulas later will be used in different methods. For example, we have integration by substitution, integration by parts, but that will be a topic for other videos. In the next video I will talk about different formulas, and maybe later about integration by substitution and by parts. But that's all for today. Thank you for your attention. Bye for now.